Lesson 28, Portfolio Greeks. Here what you will learn here, how to correctly calculate Greeks of a portfolio. So far we have investigated the Greeks at the single option level. It goes without saying that in different situations you may find yourself having to manage the risk of options portfolios. So not only the risk linked to the reactivity of the single option, but to the joint reactivity of all the options in the portfolio. To understand the dynamics of portfolio Greeks, we must first distinguish between long and short positions. If in fact an extra point of implied volatility, just to say, rises the prices of all options, this means that it is an advantage for those who have purchased the options and a disadvantage for those who have short sold them. The effects are therefore positive for buyers, negative for sellers, and vice versa. Let's look at a practical example. The call 22,000 on the FTSE index expires in 30 days, when the underlying is at 22,000 points. The implied volatility is 25%, the risk-free rate is 1%. Here the following Greeks, we ignore the gamma here. Delta is 0.52, Vega is 25.13, Theta is minus 10.77, Rho is 8.85. This means that if we buy that call, against the rise of an underlying point, we have a theoretical profit of 0.52 points. If the volatility increases by 1 percentage point, we gain 25 points. If 1 day passes, we lose about 11 points. If the risk-free rate grows by 1 percentage point, we gain about 9 points. Conversely, if the call is short sold, against the rise of an underlying point, we lose 0.52 points. If the volatility increases by 1 point, we lose 25 points. If a day passes, we collect about 11 points. If the risk-free rate grows up by 1 point, we lose about 9 points. The Greek of the short positions are therefore reversed by sign. The Greeks of a portfolio of more options are obtained by adding the individual Greeks of each option component, paying attention to the signs. A complication arises from portfolios that combine different instruments with different multipliers. For example, the FTSE MIB index futures or the mini FTSE MIB index futures in a portfolio of FTSE MIB index options. The latter are worth 2.5 euros a point. The regular futures is worth 5. The mini futures value is 1 euro per point. So what happens if we sell the aforementioned call and cover a part of the risk by buying a mini FTMIB futures? First of all, we need to understand what the Greeks of the mini futures are. Delta is 1, at least in theory, because the futures always faithfully replicate the price changes of the underlying. If the index rises 100 points, the futures rises 100 points. Why at least in theory? Because, to be stringent, if the underlying rises 100 points in 1 day, the futures rises 100 points minus the value of a day that is gone. So it's not exactly 1-to-1, but it's very close to 1-to-1. Consequently, the gamma is always 0 because an acceleration or a deceleration of profits never occurs. The Vega is null because the futures price is not linked to the volatility of the underlying. The theta can be easily calculated, making the difference between the 29 days futures price and the 30 days futures price. Indeed, theta is equal to spot price times exponential power to 1% times 29 days divided by 365 minus spot times exponential power to 1% times 30 days divided by 365, and this makes minus 0.60. Moreover, Rho is equal to the price differential that would occur if there was a 1 point increase in the risk-free rate. The initial one is 1%, the final one is 2%. So Rho is the difference between spot times exponential power to 2% times 30 days on 365 minus spot times exponential power to 1% times 30 days divided by 365. Here we change the time to maturity, 29 versus 30. Here we change the interest rate, 2% versus 1%. And this makes 18.1 points. At this point, in theory, we would be ready to put together the Greeks of the portfolio. Indeed, for the short call, the Greeks are the ones already seen. For the long mini-fib, futures on the FTSE index, called mini-fib in Italian, it's delta 1, Vega 0, Theta minus 0.60, rho plus 18.1. So the total balance would be plus 0.48 in terms of delta, minus 25.13 in terms of Vega, plus 10.17 in terms of Theta, plus 9.25 in terms of rho. But there is a serious conceptual error in this procedure. The problem here is that the value of a call point and the value of a mini-fib point are not the same. In order to compare the Greeks and thus obtain the correct portfolio Greeks, we must scale all the values to the same common denominator, their monetary value. So if we convert the Greeks into euros, we get the following. Short call is minus 0.52 times 2.5, which makes minus €1.30. The Vega is, let's go back, minus 25 points times 2.5 euros each, minus 62 €0.83, and so on for the Theta and the rho. The same applies for the long mini-fib. Plus 1 point is plus €1, €1 per point. There is no Vega. Theta is minus 60 euro cents, rho is plus 18 euros. So the total is minus 0.30 in terms of delta, minus 63 more or less in terms of Vega, plus 26 in terms of Theta, minus 4 in terms of rho. A climb of 1 point in the spot price therefore leads to a total loss of 30 euro cents. An increase of 1 point in volatility makes us lose almost 63 euros. The passage of 1 day brings us about 26 euros in profit. An increase of 1 point in the risk-free rate makes us lose about 4 euros. How long are these values correct? In principle, they do not even apply until the end of the day, because if the underlying moves even slightly, the implied volatility changes. Theta and rho change together with the moneyness. Can you see how complicated all of this is? So once again, be careful in using the Greeks because they need a very big deal of experience in order to be properly assessed. Thank you for your attention.